Hey buddies, my name is Sibusiso, but you can also call me Coach Sibu. Welcome into the Maths Buddies tutorials. In today's video, we're going to be covering identities grade 12. More specifically, we're going to be covering the identities that are involving compound angles. So please, before we can even start, make sure that you share this video if you have come across it. Share with your friends and also leave a comment and tell me how you think about this video. Did you find it very helpful? And also make sure that you also subscribe if you're watching this on the YouTube channel, or if you're watching it on Facebook, make sure that you like and also leave a comment there so that I can basically be able to generate another video. All right, so without wasting any further time, we're going to jump straight into this video. So in this video, we're mainly going to be focusing on proving identities, and then the only questions that you're going to be covering here are the ones that are going to involving double angles and compound angles. So let's go ahead and start with the first one and then talk about that one. All right, so over here we have our very first question, which is we need to prove that sine 3x is equals to 3 sine x minus 4 sine to the power of 3x. All right, so what is the first thing that we're going to do here? So mainly here what we're going to do is we're going to be focusing on our left hand side. Now what you see on the left hand side is that we have sine 3x. All right, so the first method about this is this, right? If you're given something of this nature, right, where we have a trig ratio with a number that is 3, right, all you have to do is to basically expand that number into 2x, which is a double angle, plus x, which is just a normal angle. So what basically this helps you with, it helps you to basically understand that when you have such manner, you can just apply here your compound rule, right, for sine, which is basically sine 2x times cos x plus cos 2x times sine x. All right, then now when you get to this part, remember it's very important sometimes to look at the answer that you're trying to get to, right? So here you have a a compound angle which consists of double angles. Now so that the very first double angle that we have here, it is for sine, so which means now this is going to be 2 sine x times cos x, right? But then now we still need to multiply by the cos x that we had there, and then now from here this is double angle for cos. So a double angle for cos, I like to say that you don't need to actually expand it now, because it is the one that basically looks up at the question, or what is it we're trying to get to. So that's how it basically change it, right? So now here I can see that from here you're going to get 2 sine x, and then this is going to be cos squared x, and then we're going to be getting the cos 2x times sine x. All right, so what are we going to do after this? So basically our final answer here needs to be in terms of sine, right? So which means now what I'm going to do is I'm going to change the cos squared x into 1 minus sine squared x, right? And then what about the cos 2x? Cos 2x is a double angle, so which means this one I want to change it into 1 minus 2 sine squared x, right? And then I want to multiply this with sine x. From here I'm going to multiply 2 sine x with 1, which gives me 2 sine x, and then 2 sine x with minus sine squared x is going to give me minus 2 sine, right, to the power of 3x. Then now here I have this sine x, I'm multiplying it with 1 here, so it gives me sine x, and then this sine x again I multiply it. Let me just do it this way. So I took this, multiply with that, and then took it again, multiply with this term here, so which is this one, it is minus 2 sine squared x. So this gives me minus 2 sine to the power of 3x. Now 2 sine x plus sine x, see here, these are like terms, so they give me 3 sine x, and then here minus 2 sine cube x minus 2 sine cube x gives me minus 4 sine cube x, and that is going to be exactly what is on the right hand side. All right, so we're done with the first one, so let's go ahead now and try and look into the second one. All right, so looking at on the second one here, you see that we have this very same type of trig ratio on the left hand side, which is we still have a trig ratio with an angle that is 3 theta. So which means the first thing that we're going to do on that one is what? It is going to be firstly change it into 2 theta plus theta, right, over cos theta. And then from here we're going to apply our compound angle for cos. So it's going to be cos 2 theta times cos theta minus sine 2 theta times sine theta, all divided by cos theta. And then now from here, I have two double angles, cos 2 theta and sine 2 theta. So always first keep the cos 2 theta, right? Because it has three formulas, so you don't know which one to use, right? So which means now you always change this one first, right? Because this one, it is straightforward. It is always 2 sine theta times cos theta, right? So you're gonna divide this by cos theta. Now you can see there at the top you have two terms, at the bottom you have one term. So at the top I see a common factor here, which is cos theta. So I'm going to take out that cos theta, and then when I do that, I'm left with cos theta here, and then here I have minus 2, but then sine theta multiplied by sine theta, it gives me sine squared theta over cos theta, and then this cancels with that, and then from here we have cos 2 theta minus 2 sine squared theta. All right, then now looking at the answer we're trying to get to, we're trying to have sine squared theta, or we're trying to have sine theta only. So which means now when I'm changing my double angle for cos, I'm changing it into 1 minus 2 sine squared theta minus 2 sine theta, sorry, sine squared theta. This is then 1 minus 4 sine squared theta. You see how easy this is? All right, so let's go ahead now and try and do some more complicated ones, but we're going to be doing another type of questions. All right, so we're looking over the third one now. So now looking at the third one, we see again here we have a completely different type of question here than these two ones that we have here in the previous. So basically now we're going to focus on the left hand side. So what we see on the left hand side, we see that on our numerator we have cos 5 alpha times cos 3 alpha plus sine 3 alpha times cos 5 alpha. So basically this is this is supposed to be sine. Just made a mistake here. So basically here what you see here is that we have an expansion for cos, right? So which means the first thing that I'm going to do here is going to be contracting it into cos 5 alpha. Then here we have a plus, which means previously it was a minus. Then we're going to put 3 alpha like that, and then we're going to say over cos alpha minus sine alpha. And then from here this gives us cos 2 alpha over cos alpha minus sine alpha. And then now here this is a double angle for cos. So now looking at the nature of the question, we see that we have cos and sine. So basically it means now when we're changing the one at the top, we need to change it into 2 cos squared alpha minus sine squared alpha over, we're gonna still keep the cos alpha minus sine alpha. Now if you're looking at this, this is a difference of 2 squared. So which means now if it's a difference of 2 squared, I'm going to write it as cos alpha minus sine alpha, and then also cos alpha plus sine alpha, all divided by cos alpha minus sine alpha. Now notice that I put it I'm writing now this in a bracket to show that this is going to be one term, and then I can then cancel there and there, and then I'm going to have cos alpha plus sine alpha. So this is going to be the right hand side. So that's it for this one. So now let's try and see if you can do another one. All right, so looking at this one here, we can see again here we're doing cos 5x minus cos 15x equals to 2 sine 10x times sine 5x. All right, so now here basically what we're trying to do here is we're trying to simplify this. So when you look into these equations, you can see that the easy one, or the easy way to see which one to take, you always need to look for the one that has the biggest angle here. For example, here this has 15x. Now not only that, this 15x must be able to basically be manipulated into an angle that will be 10 and also 5, right? So this then means now here what we're going to do here is that when we're taking our left hand side, right, we're going to have our cos 5x, but then now here we're gonna change that 15 into what? Into 10, right? Into 10x plus 5x, right? Now when we do that, basically here we must also make sure that we get the very same thing, right, even on this side. So now here we have 5x, so is there a way that we can basically change 5x into 10x and 5x? Yes, there is a way. So basically that way we can easily take 10x and then subtract 5x for this part. So now here we're going to be having two things like that. All right, so now before I continue, right, I'm going to be sharing with you another easy way to actually understand these two things, right? So here you see that this one has the biggest angle, right? 15. Then now we're trying to simplify this so that it contains 10 and 5. So in order for us to do that, what we're going to do is on the left hand side, right, we're going to add all the angles that are there. So what are those angles here? So those angles, if you're checking here, it is 5x plus 15x. So what you're going to do in your calculator is that to understand which number are you going to be using here, you're going to take the 5 and then you're going to plus the 15, right? And then this will give you 20. So this 20 will then divide by 2, which will give you 10. So this means now this 10 is going to be the number that we're going to be using as our first angle, right? To basically what? To manipulate 5x. So now if I'm writing 5x by starting with 10, what do I need to do with 10 to get 5? I need to minus 5, right? What about 15 now? So what do I need to do with 10 to get 5? I need to basically, sorry, to get 15, I will then add 5x, right? So that's basically the first thing that you always need to do. And then from there, you can see now we're going to basically expand this into cos 10x times cos 5x plus sine 10x times sine 5x. And then from here, we're going to say minus. And then we're going to have cos 10x times cos 5x. And then we have the plus there, so we're going to say minus sine 5x, sorry, sine 10x times sine 5x. All right, so now from here, what we're going to do, we're just going to multiply this negative in here, in this first term and this second term there. So right now we have cos 10x times cos 5x plus sine 10x times sine 5x, right? And then now from here, we're just going to multiply this here, right? When we multiply this there, it gives us minus cos 10x times cos 5x. But then when we multiply it with this negative sine 10x and sine 5x, it gives us plus sine 10x times sine 5x. All right, so now here this cancels with that, and then we have sine 10x times sine 5x plus sine 10x times sine 5x. And then now when you add these two, they then give you 2 sine 10x times sine 5x, and that will be your right hand side. All right, so now with this one, this method is some of the method that you might actually encounter as you go around. Then now, how do you know that you're supposed to use this method? Basically, you always see that here you need to change everything that is on your left and you write it like according to these angles that are here, right? Or you're changing what is on your right and then to that. But now which one do you choose now, or how do you know which one to pick? You first look at the biggest angle. So let's go ahead and try and do another example like this one so that you can basically see what I'm talking about. All right, now when you're looking at this one, for example, we can see that here we have sine 3x plus sine x all divided by 2 equals to sine 2x times cos x. So like here, it is the same as the one that we did previously. So now which means now we can either take the right hand side, try to make the left hand side, or take the left hand side, try to make it the right hand side, right? So we're focusing on the angle. So which one do you think we're going to take here? You can see here, we're going to be taking what? we're going to be taking the one with 3x, because 3x is the one with the highest angle, right? So now basically what we have to do now is we need to find two angles that we're going to be writing, right? 3x width and x width. Now to do that, we know that 3x has a coefficient of 3, so we're going to say 3 plus x has a coefficient of 1, so it's going to be 3 plus 1, which gives you 4, and then from 4 you then divide that by 2, which will then give you 2x. So this means now whatever that we do on our left hand side, if I'm writing 3x, I must start with 2x, right? Now what number do I need to add 2 with to get 3? Of course it's going to be x, so which means now this is going to be sine 2x plus x plus, and then what about this one? This one is going to be sine 2x minus x, right? Because remember, we need to start with 2x, the 2 that we got. So how do we get it to 2 again? We looked at this coefficient and that coefficient. First one is 3, then second one is 1, so they give us 4, then we divide that by 2, and then they give us 2. Then we're using that 2 as our reference to get the same value here. We only manipulated that, we didn't change it. All right. So now here we'll then see that we have our compound angle there. So sine 2x times cos x plus cos 2x times sine x plus sine 2x times cos x minus cos 2x times sine x. Let me just write it there. All divided by, just do the division, all divided by 2. Now what do we see here? We see that this cancels with that, so this basically means now we have sine 2x times cos x plus sine 2x times cos x, all divided by 2, and then when you add both of them, they give you 2 sine 2x times cos x, all divided by 2, then you divide that, and then it becomes sine 2x times cos x. All right, now before we continue and do other questions, there's one thing that I wanted to also take note here, or that I wanted you to take note here. So here in the previous one, if you remember, we had something like cos an angle minus another angle minus cos an angle plus another angle, right? And then did you see what our answer was, right? So this basically means now here, this is something that you need to note all the time, right? So if you have cos of an angle theta minus beta, right? So I'm just going to write like this, minus cos of the same angle theta, but then now in this case plus beta, and then the answer for this, it becomes 2 sine theta times cos beta, right? Because that's what we had from this one here. And then now in this one here, what I just noticed right now is that if you have, look at the nature here at the top, it is sine theta plus beta plus sine theta minus beta, and then this gives you sine theta times cos beta. All right, no, these are things that can actually even help you sometimes to just have them in mind, but you don't have to memorize them, because here you're going to be actually proving them by actually expanding. All right, so I just wanted to add that. All right, so let's go ahead and continue now with these type of questions here. All right, so now here's another one that we're given. We can see here that we're given 4 theta, sine 4 theta minus sine 2 theta, all divided by sine 4 theta plus cos 2 theta, and then it has to be equals to 10 theta. So now as you can see here, we're having the same thing here. We're having the 4 theta and the 2 theta, but then this angle is very small. So which means now here, because of we're having a mixture of angles, we're going to be doing the same thing. What was the same thing? So the same thing here is basically adding these coefficients, which is 4 plus 2, then this will give us 6, and then divided by 2, which will give us 3. Then it means now what we're going to do is we're going to be writing all of these angles using 3 as the base. So sorry, as a reference angle, right? So if I'm writing 3 as a starting angle, I'm going to write it with 3 theta. So what number do I need to add to get 4 theta? Of course, it's going to be theta. And then from here, minus sine. And then again, I'm going to start with 3 theta. What number do I need to subtract to get 2 theta? It's going to be minus theta. So you see here, we're going to be doing the same thing over again. 3 theta, we're going to add theta to get 4 theta. Plus, we have cos 2 theta there, so which means with 3 theta, we're going to subtract theta. This way, you can see that we're getting the same thing right here. So from here, we can then expand by saying we have sine 3 theta times cos theta plus cos 3 theta times sine theta. I'm going to try to squeeze everything in. Here we have minus, open bracket, sine 3 theta times cos theta minus cos 3 theta times sine theta. All right. And then we're going to say over. All right, so we're going to do the same thing here. Cos 3 theta times cos theta minus sine 3 theta times sine theta plus, and then here we're going to say cos 3 theta times cos theta plus sine 3 theta times sine theta. Okay, so now from here I just need to multiply this thing out. So here at the bottom I can see that I have minus sine 3 theta times sine theta, cancelling with sine 3 theta times sine theta. So at the top I still have sine 3 theta times cos theta plus cos 3 theta times sine theta minus sine 3 theta, because now I'm multiplying the negative in, times cos theta plus cos 3 theta times sine theta, now all divided by, let me just do that. So cos 3 theta times cos theta plus that, so it becomes 2 cos 3 theta times cos theta. Now here this cancels with that, and then here I have cos 3 theta times sine theta plus cos 3 theta times sine theta, all divided by 2 cos 3 theta times cos theta. All right, now adding these two at the top, they give me 2 cos 3 theta times sine theta over, then at the bottom they give me 2 cos 3 theta times cos theta, and then cancel these two, and then the answer becomes sine theta over cos theta, which becomes tan theta. All right, so now here let's go ahead and do our last question. All right, so now here we're looking at over the last question here. So we have sine 9 alpha minus sine 5 alpha, all divided by cos 9 alpha minus cos 5 alpha. All right, so you're going to be doing the same thing here. See here, we're trying to have 7 alpha to be involved there, so which means I'm going to say 9 plus 5 again. So what is 9 plus 5 equals to, so it gives me 14. Now divide by 2, and that gives me 7. So which means now here on my left hand side here, I'm going to be changing this part into sine 7 alpha plus 2 alpha minus sine, again 5 is going to be 7 minus 2. All right, so we're going to do the same thing at the bottom. Cos, which is 7 alpha plus 2 that, and then minus cos, so it will be 7 that minus 2 of that. Okay, so when you have this, we then get 7 sine 7 that times cos 2 of that plus cos 7 of that times sine of that, and then minus sine 7 alpha times cos 2 alpha minus cos 7 alpha times sine 2 alpha. Now this will all be divided by cos 7 alpha times cos 2 alpha minus sine 7 alpha times sine 2 alpha minus cos 7 alpha times cos 2 alpha plus sine 7 alpha times sine 2 alpha. All right, so now from here we're just gonna be simplifying everything out. So I have cos 2 alpha plus cos 7 alpha times sine, this is 2 alpha, made a mistake here, sine 2 alpha, and minus sine 7 alpha times cos 2 alpha plus cos 7 alpha times sine 2 alpha, all divided with cos 7 alpha times cos 2 alpha minus 7 alpha times sine 2 alpha minus cos 7 alpha times cos 2 alpha minus sine 7 alpha times sine 2 alpha. Alright, so now here we're going to be cancelling. So I'm cancelling the one with negative, it's minus 7 alpha. It's minus sine 7 alpha times cos 2 alpha, so which means it's going to cancel with that. And then here I have the cos 7 alpha with plus 1. Then here this plus that, it gives me 2 cos 7 alpha times sine 2 alpha over, and then here this minus with this minus, they add up to minus 2 sine 7 alpha times sine 2 alpha. So this cancels with that and this cancels with that, and I'm left with minus cos 7 alpha over sine 7 alpha. Now I know that tan 7 alpha, right, it is sine 7 alpha over cos 7 alpha. So if I then try to find the reciprocal of this, it's going to be 1 over tan 7 alpha, and then this one is going to then be cos 7 alpha over sine 7 alpha. So basically this is what we have there, so which means our final answer is just going to be that part, the 1 over tan 7 alpha, and that is going to be our right hand side. And that is all for this video. Also remember, don't forget to leave a comment, and also if you're on YouTube, please make sure that you subscribe and also click in the notification bell so that you can get notified when another video gets uploaded. And also share this with your friends. If you're on Facebook, like it, send a comment, tell me which parts would you like me to basically explain, so that I can be able to generate a video that can actually focus on the part that you're actually struggling with, and I'm going to leave you at that one. All right, cheers.